This video is going to deal with significant figures, or Sig Figs, which are also called significant digits. Sig Figs will be used to determine the number of digits in the answer to the math problems we will work this year. We must be able to determine how many Sig Figs are in a number before we can do anything else with it. A Sig Fig is a digit that represents an actual measurement. It is the measure of all the digits can actually be measured and a last estimated digit. Let's look at this nail being measured with this ruler. The ruler measures 2 millimeters. We need to have the answer to the closest millimeters. If you look at enlarged view, you can see that the nail is actually between 6.3 and 6.4 centimeters long. So we can actually estimate that the nail is about 6.35 centimeters long. So we record the answer to 3 Sig Figs. Let's figure out how to figure out the Sig Figs. There are some very definite rules to follow. Number one is all non-zero numbers are Sig Figs. In these two examples, 123 milliliters and 1.234 milliliters, there are no zeros, so every digit is counted as a Sig Fig. So in the first example, there are 3 Sig Figs. In the second, there are 4 Sig Figs. The problem with Sig Figs is always the zeros, so let's deal with that. First of all zeros between non-zero numbers are significant. In the first example, 1.002, the first number is a non-zero number, so it's a Sig Fig. The last digit is a non-zero number, so it's a Sig Fig. The first is a Sig Fig, the last is a Sig Fig. Any zeros in between are automatically Sig Figs. So in the first example, we have 4 Sig Figs. In the second example, we have 1.12003. Again, the 1 is a Sig Fig, the 3 is a Sig Fig, so everything in between is automatically a Sig Fig, including those zeros. So there are 5 Sig Figs. Rule number 3 says that zeros in the front of non-zero digits are not Sig Figs. You'll find out when we do scientific notation that we're going to drop those zeros to put the number into scientific notation. So if we can drop them, they obviously are not Sig Figs. We're just going to count the non-zero numbers and any zeros that are between those non-zero numbers. So in the first example, I would just count the 1, 2, and 3 as Sig Figs. So there's 3 Sig Figs. In the second example, all those zeros in the 1, all those zeros in front of the 1 are not Sig Figs, so we're not going to count them. So the only Sig Fig is the number 1. So there's 1 Sig Fig. In the last example, all the zeros in the front are not Sig Figs. The 1 and the 2 are non-zero numbers, so they are Sig Figs. Rule number 4 says that zeros at the end of a number must be behind a decimal point to be Sig Figs. These are our 3 numbers. We're going to look at each one individually. First of all, we're going to count the non-zero digits. In the first number, 12.00, there are 2 non-zero digits, therefore there are at least 2 Sig Figs. Now we're going to look at the end. That last 0 is behind a decimal point. In fact, both of those zeros are behind the decimal point, so they are both Sig Figs. So the zeros at the end are at the end and they are behind a decimal point, so in this example we have 4 Sig Figs. In the next example, again, the zeros are at the end and they are behind a decimal point, and we also have the zeros in the center. We're going to go back to Rule 2, which says zeros in the center or in the middle of the number are Sig Figs, so we're going to count those also. So here we have 7 Sig Figs. Our last number has no decimal point, so we count the 2, so the zeros at the end are not behind a decimal point. They are not Sig Figs. This number may have been rounded off to 1200 to give 2 Sig Figs, and there are only 2 Sig Figs in this particular example. Rule number 5 is that if a decimal point is placed after a final 0, it means that those zeros are significant. You're not going to go through all the hassle of writing a decimal point for nothing. So if that decimal is actually written down, all of those zeros become significant digits. So in this example, there are 4 Sig Figs. Now, we're going to stop and practice counting Sig Figs.